Well, thank you for joining me on this question. We're going to be looking at exercise 2M, question 2, part 2. And we're looking at f of g, and we're looking at g of f. So let's have a look at f of g. Now we've got f of g of x, which is f of, now g of x is the square root of x squared minus 4. And so we substitute that into our formula, so we get x squared minus 4 plus 1, the absolute of that. And that is our g of f, f of g. Let's look at g of f, which is g of f of x. And so we put our absolute of x plus 1 into our g function. So our g function is the square root of x squared, so the absolute of x plus 1 squared, and then subtract 4. And if we were to look at the domain and the range, the domain of f of g is the range of the g function. So whatever our g function is, that's what we're allowed to substitute into f of g as our domain. So let's have a look at what we're allowed here. And the range of g, because it's the square root, what is the domain of g? Well, the allowable domain of g restricts our domain of f of g. So let's just backtrack, find out what our domain of g. And we're only allowed to have the square root of positive numbers. So we can only, x squared minus 4 has to be greater than 0. So x squared is greater than or equal to 4. So the square root x is going to be greater or equal to 2. So that's our domain of g. And that becomes our domain of f of g. Now let's see what range we get for that restricted domain. Now when we come across here, we are adding 1 to it. So we initially had a range, if I can, we had a range here of from 0, because the square root of 0 is our smallest value. So it was from 0. Then if we add 1 to it, our range increases. So our range now is all values greater than or equal to 1. And then the absolute of those values still becomes 1. For g of f, what is our domain of f? And we can use all real numbers, because you could substitute any real number in there. And then that becomes an absolute, which means it's never negative. So we can put any value in there, that's fine. and then we end up with a 0 minimum. And when we put a 0 minimum in here, we've got our minimum value as 0 squared, and then we can't subtract 4, can't get -4. So if we had find out what x values we could have here. Initially, we've got x plus 1. We want that to be greater than 0. So x plus 1 is greater than 4. And so if we take the positive x plus 1 is greater than or equal to square root of 4, which is 2. And x plus 1 will be less than or equal to -2. So it's either greater than 2 or less than or equal to -2. So x is greater than 1, and here x is less than or equal to -3. So our domain is restricted from, our domain of g of x is restricted where x is less than or equal to -3, or x could be greater than or equal to 1. That's our domain. Now substituting that into our value here, the square root, the smallest number in here is 0. So we get only positive numbers because the square root, therefore our range of g of f is all y values such that y is going to be greater than 0 because the minimum range is 0. I hope this has helped. Until next time, stay happy.